Today we will be having a discussion on the AC circuit. Fundamental. Let us write V of t. Small v means instantaneous value, function of time. I can write 5 of t. We can also write e to the power minus t. We can write t minus 4t squared in this way. Or we can write here as Vm sine omega t. The moment we are writing in terms of trigonometry, so let us explore the trigonometry first. Let's say I'm talking about sine of theta, and we say that let us say V of theta is equal to Vm sine theta. In this particular case, we can get the output voltage waveform or the voltage waveform of V of theta with respect to theta. It would look like a sine wave where starting from 0 and at one time period this will be 360 degrees. Here it is 270 degree. This one is 180. This one is 90 and like that. And the peak value is the Vm. This is what this equation represents. Now, if the theta is actually nothing but angular displacement, and we can write in terms of omega t. Omega is the angular velocity multiplied by time. So, if the same waveform, let us draw again. Can we represent in terms of time? We know that theta is also is equal omega t here. We can also represent this angle in terms of radian. That is, instead of 360 degree, we can write 2 pi. 180 degree can be written as pi. This can be written as pi by 2. And here it is written as 3 pi by 2. Now if I rewrite the time here, time can be written as omega theta divided by omega, or theta by 2 pi into capital T. That means we can write when theta is equal to 0 degree, the time is equals to 0. When theta is equal to pi by 2, t is equal to t by 4. You can use this relation over here. And if theta is equal to 0, obviously t is 0. And if theta equals to pi by 2, here we pi by 2, pi cancel. This will be t divided by 4. Similarly, if theta equals to pi, t is equal to t by 2. And theta equals to 3 pi by 2, t is equal to 3t by 4. And theta equals to 2 pi, time is equal to t. That means we can write here this is as v of t starting with 0. This can be t by 4. This is t by 2. This is 3t by 4. And this is t. And we can get the same waveform. And here we can write in terms of time. So by dividing this term by omega or dividing this term by omega, we can get the function of time vt as a function of time. Earlier that what we are getting theta, v of theta as a function of theta. So in this way we can write the voltage v of t in terms of Vm sine of omega t. Correct? So next we have, let us say we have got a supply and here we have got a load. For instance, let us say resistive load. The supply is V of t and the current is I of t. Now the current I of t is obviously V of t divided by R, and that is nothing but Vm sine omega t by R. The term Vm by R is a constant which can be written as Im sine of omega t. We get the expression of current. Now this current is a waveform. This is a waveform of the current which is given as time and I of t. And the time period is given as capital T, like this. Now if we are asked two things, number one, average current, second is RMS current. So what is the meaning of average current? Average current is the amount of charge that is being transferred during a given time. So if I ask that the average current, that is, what is the charge Q, you know that Q is equal to I into T. So that is the area under this curve. This is the charge. For a AC waveform, the total charge transferred during a given time period, during a time period T, is equal to 0. So in order to calculate the charge transferred, what we can do, either we can go for invert of that and calculate the amount of charge that is being transferred. In this way, we can calculate what is the average charge that is being transferred. So if we add this area and this area, what you have, the DC current, which is, and if we take the area of the DC current, let us draw here. Suppose we will have another line like this, and this current is now DC for the same time. Now if I say the amount of charge transferred during a DC and the amount of charge transferred for the AC, if these two Q here and the Q here are same, then this value of I is called the average current. That's a simple thing. So what we do, we assume that the charge Q is equals to, for a DC it is equal to I into, for a time T, I into t, whereas for AC it is integral from 0 to t I of t dt. Since if we integrate from 0 to t, it will sum up to 0. So what we did, we take 2 times from 0 to t by 2 and find I of t dt. So what will be? What we are going to get is 2 times of integration 0 to t by 2. I t is Im sine of omega t dt. Further integration will give us 2Im sine omega t is minus of cos omega t by omega and 0 to t by 2. This will further give us 2Im. When you put t by 2, we can write minus of cos 2 pi by t by 2 minus of this will plus cos 0. We know that cos 0 is, this gives 1, and this will be 2 and 2 cancel, t and t cancel, cos of pi is minus 1, so this will also lead to 1. So 1 plus 1 is 2. So what we get is 4 Im. This is the value we are getting here. And the omega which is left out over here, this omega is nothing but 2 pi into t. So if we solve it, gives me 2 Im by pi into t. So on the left hand side we have I into t, so that we will write here this I is nothing but I average into total time. Now if I cut this value of t, if I cancel this t, so what we get, I average is equal to 2 Im by pi. This is the value of the average current. How do we get? We get it by equating the charge that is being transferred during a time period t. Now, in order to get the RMS current, we need to evaluate what value of DC current that would flow through a resistor for the same time, and it will produce the same amount of heating. So for average current, we calculate what is the amount of DC current that will produce the same amount of, that would transfer the same amount of charge. And for RMS current, we will find what is the current that will flow from the same resistor for the same time, and it will produce the same amount of heat as of AC. So for that, we will equate, for RMS current, we will equate the heating due to DC current, let us say, equals to heat due to AC current. And that DC current is nothing but IRMS square into R into T. And that's the heat, and is equal to integration of 0 to t, and here we have I square t into R dt. So here what we can write, Im square sine square omega t, or we can take out dt. Further, we can write it as Im square into r divided by 2 and 0 to t 2 sine square omega t dt. So if we split this 2 sine square omega t dt, it will be, so Im square r by 2. This will be integration from 0 to t 1 minus cos 2 omega t dt, which is equals to this will be t minus sine 2 omega t by 2 omega, and the limit is from 0 to t. Now this term will be equals to 0, since we can write 2 into omega into t, that is nothing but 2 into 2 pi by t into t is capital T, so this dt cancel out. This is sine of 4 pi, which is equal to 0. And what we left out with, Im square r by 2, here we write out t. So on the left hand side, what we have, Irms square r t is equal to Im square r by 2 into t. So this r cancel out, t cancel out. What we finally have is Irms, which is also written as a capital letter I, is equals to root over of Imax square by 2, or I can write Im by root 2. So finally what we get, the average value of the current is equal to 2 Im by pi, and the RMS value of the current is equals to Im by root 2. So let us summarize all. To summarize that, we have started with AC circuit fundamental, and we get to say that we can write in terms of V of t as a function of time. To evaluate, and we will use a trigonometry sine theta because it is periodic and continuous. So we know that V of theta is equal to Vm sine theta, which I can represent by a sinusoidal waveform. We know that theta is written as in terms of degrees, and that's why we can write in V theta. Also we can write in radians if we use omega t. If we divide this term by omega, we can get the in terms of time, and if we put the values of theta in different values, we can get the time. And what we can correlate a time period in one time repetition of the cycle before the repetition of the same cycle, the total time is capital T. And then we can represent the x-axis as small t. So finally we got that if voltage is there, so the current can also be evaluated at V by Vt divided by R, and we get the current in terms of Im sine omega t. Now our objective is to find out what is the average current and the RMS current. So average current is the amount of charge transferred during the one time period. So in a time period, so the since the positive charge is equal to negative, so it is cancel out to 0. However, if we invert this and we calculate the amount of charge during this by taking equality or we calculate the amount of charge in half cycle and multiply by 2. It will give us how much amount of charge is being transferred. But if you say the AC circuit, the amount of charge transferred is always 0. However, to calculate the amount of charge transferred, and that is called the average current. So average current is that DC current which when flow during the same time, it will same amount of charge is being transferred. So we take the relation of charge transfer as Q, which is equal to I into T, and integration on the other side, and we make it 2 times of integration from 0 to T by 2. And here we evaluate Im sine omega t with integration of sine omega t, and finally when we get these terms of omega, 2 Im by omega we split into 2 pi by t, and we get this value, and finally we get average current. At the time of finding the RMS current, we evaluate the heating effect, the amount of DC current that produces the same amount of heat when AC current is getting flow. So AC current heat equation will be 0 to T I square T d into R into dt. So when you put this value, ultimately we get IRMS is equal to Im by root 2 and I average equal to 2 Im by pi. Thank you very much.